Welcome to the lecture on sedimentary rocks. I think this is the third in the Chapter 6 series. Collect all 7. It's good to be back, isn't it? And I'll try to make this fast. I always do, but it never works out. Oh, shoot. Time to start my clock. Just a second. Okay. You may have noticed a difference in sound lately. I decided to use a headset too, since you guys have to. It seems only fair. Okay, sedimentary rocks. Where do they come from? Well, they make up about 3/4 of Earth's surface, but they're only a small part of the Earth. You ever go around your house after not dusting for a while and find dust on your countertops or your chest of drawer tops? Well, sedimentary rocks are like that. They're just made out of pieces of other things that are like the dust on the surface of the Earth. Under a little heat and under a little pressure, they can change from sediments into rocks. Sedimentary rocks. It's pretty simple. They usually form in water. Sometimes they're in dunes, they're in riverbeds, but they're always where things stack up. There are 3 types of sedimentary rocks. Clastic. A clast is a piece of a rock. Chemical, left behind by either evaporating or 2 materials going into a liquid and one of them falling to the bottom because they make an insoluble compound. Or organic, from living things. First, let's look at the clastic rocks. This is how your book describes them. 3 major clastic rocks are conglomerate, made of big pieces, sandstone made of, well, sand, typically quartz grains, and shale. Now, in conglomerate, you have large fragments. You can have anything in there. In fact, a conglomerate rock can be made of a piece of sandstone, a piece of shale, and a piece of conglomerate all together. A conglomeration is just a bunch of things thrown together. There used to be an old restaurant called Bobby McGee's Conglomeration. What kind of furniture did they have? Everything. They had stuff from the 1800s, recent stuff. For the salad bar, it was a bathtub. One of the chairs was a toilet. It was everything thrown together, and that's what a conglomerate rock is. You can see these if you go hiking on Trail 100 near 7th Street and Thunderbird. The old lava boulders, the basalt, have all been glued together by calcium carbonate. Also, right near North Canyon High School, where the road goes up over the hill, on the south side of the hill and the north side of the hill, through the outcrop, you will see conglomerate rock that's kind of forming. It's not very well consolidated. Now, these can be permeable. Sandstone can be permeable. I used to have a piece of sandstone I could hold in my hand in class. I would pull out a beaker of water, like a glass of water, and I'd start pouring water on top of the sandstone. And I'd just keep talking about sandstone, and the kids would keep watching, and the water would disappear into the rock. Then I'd ask them, where do you think it's gone? And they'd think about it, and while they were thinking about it, the water would come out of the bottom of the piece of sandstone. It was that permeable. Shale, which is made out of typically little pieces of clay, which is hydrolyzed feldspar, or feldspar combined with water. Little platelets, is very non-permeable, which is why we grind up this stuff, turn it back into clay, and line our landfills with it. Because when it gets wet, the clay expands, sealing in all the leaching material called leachate. Okay, here's a way to break down clastic rocks. Coarse-grained, medium-grained, fine-grained, or less than 1/256th of an inch. If you have a soil sifter, which I've shown you in a previous lecture, you can sift these things out. And there are 2 types of conglomerates, really. If it's round, it's called conglomerate. If it's angular, it's called breccia. You get sandstone, you have siltstone, and you have shale. Your book doesn't talk about siltstone very much. Where do clastic rocks form? Well, mostly any place where water will deposit things. Now, this is just a schematic. Think of this as the ocean, and think of this as high in the mountains. High in the mountains, where the sands and gravels get dropped, you end up with conglomerates, or in stream beds. Out where the river begins to slow down and the sand gets dropped, you get sandstone. A little further out, you get silt. And way out in the deltas and in the ocean, where you have clay settling down to the bottom of shallow seas that are very calm, you get shale forming. It's not just in the oceans. This was taken by one of my students. If you look at the edge of your house, water drips off and tends to carry away stuff depending on the speed. It's just the same as this. Crazy. Take a look. The big stuff, the finer stuff, and then out here, really fine stuff. The big rocks are here. This would be conglomerate. This would be like the sandstone. And here would be the silt and the clay. This would be up in the mountains. This would be down by an ocean delta. This is really kind of cool. It happens all over the place. Now let's look at the real rocks. This is the largest clastic sedimentary rock. It is conglomerate. Again, it's just a conglomeration of things. Starts out as this, like you're going to see by North Canyon High School on Union Hills Road, and turns into this over time. Now, if it's angular, meaning it hasn't gotten tumbled in a stream bed, these obviously have been tumbled in a stream bed, then it's called breccia because it's just accumulated and then changed into rock. Sandstone, well, it's made out of sand. It looks like sandpaper. And it forms these really neat formations in northern Arizona and southern Utah. It's great for mountain biking on. If you have a chance to go up to Moab, I should have stuck a picture of Moab in here. You can bike on it. Imagine on top of this cliff, biking across this stuff. This is just layer after layer of sand. In this case, it's sand that was stacked up in dunes, so it's not entirely horizontal. These are called crossbeds. We will talk about this in a while. Sandstone, when it's stained by iron, makes these really nice stains. We cut them apart, make them into coasters, and sell them for big money. This comes from around Drake, Arizona, south of Ashford, north of Prescott. Here's sandstone up near Window Rock, Arizona. And it goes through a differential weathering. Some parts of it are softer, some parts are harder. It's just beautiful. More sandstone and more sandstone. This is in Canyon de Chelly, I think. You can see how the sandstone has been colored here over time. And here's sandstone in Lake Powell. Sandstone can be glued together with either silica, what the sand is made of itself, or iron, and it looks like there's some iron here that has been leached away, or calcium carbonate. If it's calcium carbonate, you know it because you put acid on it, hydrochloric acid from your pool, and it'll bubble. If it's iron, it's going to be red. If it's not one of those two things, it's probably just glued together with silica. Believe it or not, small amounts of quartz can dissolve in water. This is Lake Powell, and yes, the water is dropping. Imagine what this was like when the water was up to here. And here are sandstone pinnacles in Monument Valley, Arizona. Down here, softer, much less resistant than the sandstone, is the next kind of rock, shale. So we've gone from conglomerate and breccia to sandstone to now the really fine kind of rock, shale. Again, three types of cements, or calcium carbonate that'll bubble, iron that will be red, and silica, it's probably the other cement. Now, the finest type of sedimentary rock we were just talking about is shale. It's compressed mud. Mud is nothing more than little teeny clay particles, hydrated feldspar. It can be called kaolinite. But little teeny platelets, just like platelets in your blood, and they stack together like sequins in a jar and then get compressed. There really is no cement in here, and this makes a very impermeable rock. However, because it's in mud, when it was forming, you can often find fossils in here. So this lady is pulling apart shale layers looking for fossils. Shale, because it forms in an organic regime or environment, has small amounts of bitumen or oil or lignin in there. Carbon-based materials. What we started doing lately is drilling down into the ground, shattering this under high pressure with all kinds of toxic chemicals that we inject down in here, and then bringing back out natural gas that comes through these cracks. One of the problems appears to be is, well, we leak a lot of methane, which is natural gas, to the atmosphere, and methane is really damaging. It's like 30 to 70 times more damaging than carbon dioxide. We don't gather it all. And two, we've been promised that all these toxic chemicals that the oil companies don't have to report won't get back up to our drinking water. Unfortunately, that hasn't been the case in every situation. They're working on it. Okay, in the Grand Canyon, you can see sandstone that we just talked about, shale. We haven't talked about limestone yet, but we will. Limestone, shale, and more sandstone. Lots of sedimentary layers. Now, chemical rocks. Two types of chemical rocks, evaporates and precipitates. If you leave salt water out on your counter overnight and the water evaporates, there will be salt left behind. It's the same thing happens in nature. When water evaporates, anything that was in it is left behind. If you've ever been in chemistry class or seen a magic trick where the magician or chemistry teacher, who might be a magician, pours one clear liquid into another clear liquid and something forms and settles to the bottom, that something that settles is a precipitate. Anything that falls down to the bottom is called a precipitate. That's why rain is, well, precipitation. When you have one river dumping a chemical into the ocean and another river maybe dumping another chemical into the ocean, those two chemicals may meet, they might do a double replacement reaction, and what they form drops to the bottom of the ocean. That's called a precipitate. Now here's a little chart of chemical rocks. If you have calcite, very easily dissolved in water, as we know from an earlier chapter, it can make limestone, travertine, coquina, which is nothing more than squished shells that look like a granola bar, fossil limestone, or chalk. And I forgot to include a picture of coquina. If quartz is left behind by evaporating water, you end up with something called chert or flint. If gypsum is left behind by evaporating water, you get rock gypsum. Halite being left behind is rock salt. If you have plants left behind, they're not really chemical, they're organic, and we call it bituminous coal. Let's look. This is limestone. Our main use of limestone is as cement. We heat up the limestone, we drive out part of the oxygen that leaves calcium oxide, we mix it in with sand and rocks. That makes cement for our roads, our houses, our stucco, the bases of our houses. We wouldn't have our civilization without it. It's also used as a white pigment or a filler in toothpastes and paints. And limestone is about 10% of all sedimentary rocks. Sedimentary rocks cover a good portion of the Earth's surface, but they aren't the biggest kind of rock on Earth, just on the surface. Here is a limestone mine. I forget where this is, back east somewhere. They're just slicing down to the rock, grinding it up, probably making it into cement. Or they could be quarrying it for buildings. Where does limestone form? Well, think of a coral reef. These guys, little critters in the water. Think of them like jellyfish, except they're upside down with their legs upwards. They extract calcium carbonate from the seawater and they make little shells around them. That's what coral is. Then their buddy does the same thing, and their buddy does the same thing, and their buddy does the same thing. Then when they die, new little coral organisms grow on top of them, and the coral reef goes upward, upward, upward. This is a natural kind of limestone. We can prove it because when you drop hydrochloric or pool acid on it, it bubbles or effervesces. We build out of limestone, but one of the problems is, as we create pollution in the cities with automobile exhaust and coal plant exhaust, it creates a mild acid out of the rain, and this is what can happen after just a couple hundred years to buildings. Actually, I think this is on, I don't know, I was just at Notre Dame and I don't remember seeing this, but it looks like something from there. Yeah, the Notre Dame in Paris, right along the, what is it, the Seine. If you make buildings out of limestone and water gets into the buildings, it will leach out some of the calcium carbonate and create what's called an efflorescence. Better stop here.